On April 26, 1956, a converted wartime tanker called the Ideal X quietly slipped out of Port Newark, cutting a path toward Houston. It carried 58 trailer vans lashed to its deck. Watching the ship leave, Freddie Fields of the International Longshoremen's Association remarked that he'd like to sink it. He understood immediately, a reality that would take the rest of the world another decade to notice. The man behind the operation, Malcolm McLean, had founded a trucking company in 1935 and driven the routes himself. He arrived at the docks with the perspective of a hauler, proposing a specific set of dimensions that would force the maritime world to adapt to his overland logic. Standard design education usually suggests starting with the user, understanding the person, then shaping the object. This was the opposite. This was a rigid module, finalized before any of the ships or cranes that had to interact with it were even built. McLean initially secured patents for his container designs, treating the box as a proprietary product that he could control. Then he made a radical pivot. He issued a royalty-free lease to the International Organization for Standardization, effectively giving his designs away to the entire industry. Opening those patents transformed the box into a neutral interface. By removing the cost of entry, McLean invited the rest of the world to reorganize itself around his specific grid. He traded a short-term monopoly for a world that had no choice but to build its future against his dimensions. This agreement was formalized in 1968 as ISO 668, the international standard that governs how freight moves. The standard allows for some variation. The length of a container can double from 20 to 40 feet, and the height can increase to accommodate high cube cargo. But the width is fixed, 8 feet, every single time. This unmoving number is the module. It works precisely because it ignores individual preferences. No one has to love the look of a shipping container for several billion tons of freight to move through it every year. This 8-foot module dictates the internal geometry of the modern world. Every cell guide inside a container ship's hull is spaced to match it. The mechanical span of every dockside gantry crane was engineered around this exact dimension. Out on the highways, lorry trailers are sized to carry that width to the inch. Even at the architectural scale, the distance between warehouse bays and the depth of dock aprons are permanently poured in concrete to accommodate this single number. Standardization is a design act that removes options on purpose. None of these massive systems were designed independently. They were all grown from a preset mathematical seed. The danger of early standardization is that a module that is even slightly wrong remains wrong for a very long time. The width chosen in the 1960s still constrains our buildings and vehicles today. Freddie Fields' desire to sink the ship was a rational response to a design that automated his livelihood. He saw that a standardized box replaced the need for manual cargo handling, making the labor of thousands of men obsolete. He recognized the long-term impact of the module before the architects even began their work. Entire port cities that had thrived on manual breakbolt cargo were either physically leveled and remade into these geometric grids, or they were abandoned. Once the infrastructure is tooled to a specific size, the module is no longer a choice. It becomes the mandatory ground everyone is forced to stand on. This same logic applies to modern modules, like battery cell formats, server rack units, and pallet footprints. These dimensional choices are settled in week 1 by whoever happens to be in the room. Because they are settled early, these foundational constraints will likely outlive every other design decision made on the project. Modularity dictates the shape of everything that follows. It is the high-leverage decision that sets the boundaries for the entire engineering lifecycle. Design decisions are cheap as a sketch, but brutal once tooled. See every angle before you build. Made at Depix.